All right, energy, size, activity, and environment. Sorry. Energy allocation and use. Chemical energy from food is going to be used for activity and metabolism. Food is broken down by enzymes and converted to there we go. ATP, remember, cellular energy. What process? Cellular respiration. And cells use that ATP for energy. With all of this, any heat generated is usually eventually given off. Quantifying energy use. Your metabolic rate is the amount of energy an animal uses in a unit of time. It can be measured in joules or calories or kilocalories. 1 kcal is equal to 1,000 calories, which is equal to 4,180. I don't know what number that is. It's supposed to be a 4 joules. When nutritionists talk about calories, or you're looking at a diet and it's talking about calories, it's the big calories, it's kilocalories. Ways to measure this. Let's see. Ways to measure. You can use a geez Louise. That is not how you spell that. Like calorie. Calorimeter. Or you can do oxygen consumed or CO2 produced. Or you can do over a long-term period the calorie content of food versus energy lost in waste. Remember, when you talk about food, we'll put it over here. Carbs and proteins have approximately 4.5 cals per gram, and fat has 9, double that, cal per gram. Minimum metabolic rate and thermoregulation. Your basal metabolic rate is the minimum metabolic rate of a non-growing endotherm at rest that has an empty stomach and is not experiencing stress. This is what it takes to keep you alive. Just breathing and your heart beating. It's at a comfortable temperature range, so no heat is being generated or given off. And again, to keep you breathing, average for humans males is 1,600 to 1,800 kilocalories, and females 1,300 to 1,500 kilocalories. Your standard metabolic rate is metabolic rate of fasting non-stressed ectotherm at rest at a particular temperature. For example, the American alligator is 60 kilocalories. influences on metabolic rate. Metabolic rate is affected by size, age, sex, activity, temperature, and nutrition. If we look at size and metabolic rate first, bigger animals require more energy, and that is a relatively constant rate here. It's approximately your body mass to the 3/4 power. So it looks like, have Miss Reeves help you with the math. So it only makes sense that obviously a shrew does not need as much food as an elephant. But if you look at the if you look at calories per gram of body mass, mainly how much it takes, the shrew, tiny rat critter, is going to require a lot more than the elephant per body mass. This is actually kilograms. I think I said grams. Smaller animals have higher metabolic rates per gram. It results in higher breathing rate, higher blood volume, higher heart rate, and therefore they must eat more food per gram. Oh. If we talk about activity, your BMR is what it takes to keep you alive. Most humans have a daily metabolic rate of approximately 1.5 times their BMR. What was that? Okay, there we go. And that's low. Most animals have 2 to 4 times their BMR. And that's because we're mainly sedentary. Maximum metabolic rates occur during peak activities like weightlifting, swimming, or sprinting. And the maximum metabolic rate that an animal can sustain is inversely related to the duration. So you can do those things for short periods of time, but not long. What's next? There we go. Energy budgets. If you, this is a comparison of different endotherms and ectotherms. You have a human female, a male penguin, a female deer mouse, not deer, deer mouse, and a female eastern snake. Why is the male thrown in here? Because they take care of the eggs and the babies. Reproduction is included because it's important to the survival of the species. Unhuman, most of the energy expenditure is on the basal metabolic rate, less on activity. And again, only the growth here you'll see accounts for 1 kilogram or 5 to 6 pounds of weight gain. You don't see any growth here because once they reach adulthood, penguins and deer do not grow, or mice do not grow. Pregnancy for humans is only 5 to 8% of the year's energy requirements. A male penguin spends most of its energy on activity. See, it's almost half. Because he has to swim to find food. It's low on thermoregulation, which is this color here, because he's very well insulated and he's large. 6% on incubating the eggs, because he has to incubate the eggs and bring food for the chicks. Sorry. The deer mouse is so small it uses lots of energy for thermoregulation. Here. because it loses so much heat because it's tiny and so it has a large surface area to volume ratio. Ouch. The snake does not have any thermoregulation, this orangish color. Not here. Cost because it's an endotherm, and it spends a lot more on growth because, like all snakes, it continues to grow throughout its life. So this is just different ways different critters use energy. Torpor and energy conservation. Torpor is a decreased state of activity and metabolism while avoiding difficult or dangerous conditions. Bats feed at night, so they go through torpor during the day. Chickadees and hummingbirds feed during the day and go through torpor on cold nights. Hibernation is a long-term torpor. It's an adaptation to the winter cold and food scarcity. When animals hibernate, they have a decrease in temperature. It can be very dramatic. They sometimes undergo periods of arousal where they kind of wake up, get an increase in body temperature. They're not really going to be that awake. And so they're briefly active before resuming hibernation. Estivation is the slow metabolism inactivity in the summer. Remember, hibernation was winter. Estivation is to enable survival during high temps and scarcity of water. The circadian clock actually ceases operation during hibernation in European hamsters. This is new findings in a new French study before they were able to still find signs of that circadian rhythm maybe during those periods of awakeness. Let's see. Oh, look. "40 is done."